In 11.2h, let's interpret computer output for a chi-square test based on a two-way table. So here we have, if you just read the computer output, a chi-square test where we have expected counts are printed below the observed counts, and the chi-square distribution or contribution is printed below the expected counts. So what you're actually seeing here for this particular cell right here, it looks like we have 2 rows of data, so in this one, but we're looking at city 1 and city 2. In here, all they're telling you, that's observed, that's expected, that's the chi-square contribution. If I tally up all of the chi-squareds right here, what you should end up getting is the final chi-squared, which is stated right there at 15.33. We can just confirm their degrees of freedom. Remember, that's just rows minus 1 times columns minus 1. So we have 2 minus 1 times 2 minus 1, which is 1 times 1, or 1, which makes sense. We can also see here that we have a total of 459. And then the p-value is lastly stated here, which makes sense, folks. Chi-squared 15.33 is a pretty big statistic. So on here, we clearly do have enough information. We may ask maybe what alpha was set at. In this case, let's assume 5%. So if we made a conclusion, P is less than alpha, therefore we reject H sub O, and we would conclude H sub A, whatever that was actually stated as. So ultimately, we have talked about 3 different chi-square tests. You do want to become proficient on being able to tell the difference between them. I think the easiest way is right here. Just remember, goodness of fit is 1 sample, 1 variable. Test for homogeneity, it's that 1 variable, but 2 or more samples. And then the chi-square test for independence or association, whichever word you want to use. In this case, it's 2 variables, but only 1 sample. To review how you would state the hypotheses for these, this is just a nice recollection. Remember to recall, for goodness of fit, our null hypothesis means there's no difference. But in the alternative, this is where we think there is a difference. It is not consistent what you're going to say. For homogeneity, that's very similar too. We're talking about the distribution as just their distribution of no difference. However, in the alternative, we think it is not the same. When you get to independence or association, if you choose the word independence, your null hypothesis, be careful, you're saying variable 1 and variable 2 are independent, because the alternative is we think that they actually are not independent of each other. We think there's some dependency. If you choose the word association, it's backwards. The null hypothesis, there is no association, but we're doing this test because we think there is an association. So be cautious. The AP board tends to not care if you use the word independent or association, but the null and alternative hypotheses for those are actually backwards in terms of their use of not. Now for the conditions that you want to check for that, keep in mind the one condition for random, large size, and independence. All 3 of those are going to be the same for here. However, computing the expected counts for homogeneity and independence, you have to do rows times columns divided by the total. And that's where the mechanics are going to come in terms of your degrees of freedom. Recall, state the test. So chi-square goodness of fit. This is just the chi-square test on the calculator, and so is this. These 2 actually run the exact same way on the calculator. Their degrees of freedom are calculated the same. Careful, goodness of fit is number of categories minus 1 for degrees of freedom. The chi-square CDF and the chi-square calculation for the statistic are exactly the same. And then they do basically wrap up in a similar fashion for your conclusions, just like any hypothesis test would be. We're going to conclude them in the same way. And then lastly, we are done with Chapter 11 now, and what you should notice is we never talked about constructing confidence intervals for those. We do not do confidence intervals related to these various chi-square tests. They truly are just the tests, so we are officially done with Chapter 11.